Hello, my name is Nicholas Parsley, and I'm currently the lead developer for AGVis. Today, I'll be talking you through the Independent Data Reader, or IDR features. The Independent Data Reader is the contour equivalent to the multilayers topology, and conveniently, all of its features are also accessed the exact same way. The IDR handles displaying heat map animations based off of user-provided data. The exact formatting for this data can be found at AGVis' documentation, which is hosted at agvis.readthedocs.io. It should be noted before we begin that to use the IDR, you must also include multilayer data, since the IDR relies on nodes being present to function. As you can see, I've already started up AGVis by local hosting with python-m http.server. As I mentioned before, the IDR is accessed by uploading a file, so I'll upload one now, see what happens. Now, first thing you might notice is there is a bit of a visual bug. We're trying to address it. If you start and stop it, it just immediately goes away. So, as you can see, all the multi-layer UI is here with additional controls underneath it. These are the IDR controls, and they're functionally the same as the base AGVis configuration controls, with just the unnecessary ones removed. Now, start with the playback bar. This controls the speed at which the animation plays, when it starts, when it stops. You can pause it, restart it, and the input, of course, also affects this timer here, which just shows where in the animation you are. Between the timer and the playback bar are the different variables. You can switch between them with these buttons. We have voltage frequency, voltage magnitude, which is just called voltage, and voltage angle, which is called theta. So as you can see, switching through them drastically changes how, like what is shown for the animation. Below these are the ranges, basically what causes what color to show up where on the heat map. I'll admit, I'm not the best at knowing what ranges should be set to, but if I adjust the frequency one here and change it back, you can see it's a pretty drastic difference. Below all that is the timestamp. This affects how the timer displays, so I'll just pick random set of days, time. That'll go for 1.5 days per tick. Restart it, and as you can see, the timer now increments to what it's set to. Now, of course, one of the big features of multilayer was being able to show more than one set of data at once, and the IDR carries this over. I'll pick another simulation to show. Let me switch its display, and as you can see, they're totally independent. You can pause this one, the other one will still continue. You can restart them, they can have different variables, different timer settings, different settings going at the same time. They are completely independent, with the exception that they can overlap a little visually if you put them too close. Now, I'd like to discuss a topic that's a little bit more advanced. So let me clear these out, so we have a nice clear screen. So as I mentioned before, the expected variables for IDR are voltage frequency, magnitude, and angle. You don't have to use these. AGVis is actually capable of creating a heat map for basically any data, so long as it's nodal. If there's one data point per node per variable, it can make and animate a heat map. AGVis is completely agnostic to what the data is, and the internal functions are not dependent on the data explicitly being one of those three variables. You can make one temperature, another price. The options are genuinely limitless so long as they're nodal and you properly specify them in your input file. Now, I'll be the first to admit that this is a little hacky, and we're currently working on making this a full supported feature, but if you want to access it now, it is available, so long as you're willing to accept that the variable names are not going to align with what they're actually showing. Alright, I think that's just about everything. Thank you for your time, and I hope you will continue to follow the development of AGVis.